Hello everyone, my name is Rajesh Kumar and I'm your DevOps SRE DevSecOps coach. I have close to 18 plus years of experience working in multiple MNSEs around the globe and having in-depth knowledge of DevOps, SRE and DevSecOps. So I would like to introduce you one certification program in a DevOps, and that is we call it DevOps Certified Professional. Now this is a 2 months of program, 25 tools of DevOps you will learn, and apart from that you will also get the access to the LMS, lifetime access to the videos portal. It's a certification program, and you will have 25 assignments and 2 projects along with it. It's a completely weekend program, so here you have classes on Saturday and Sunday. So as part of this course, you will learn multiple things. Here you see that you will learn Linux, AWS, Docker, Jira, Confluence, Python, Git with GitHub, SonarQube, Maven, Gradle, Packer, Artifactory, Selenium, JMeter, Ansible, Kubernetes, Helm, Terraform, Jenkins, Datadog, Splunk, and Neuralink. Now, how do we, apply for this? So how can you reach out to us? So you have a WhatsApp number and email ID, so please reach out to us and we'll help you to onboard this program. Apart from this DevOps certified professional programs, we are offering other certifications as well in a DevSecOps, SRE, and one of the very comprehensive programs which we have is in Master in DevOps Engineering. Yeah, so feel free to get in touch with us and then enroll for it. Thank you. Okay. Can you see my screen, all of you?
Yeah.
Yeah. Okay. So, so the first question is, what is Kubernetes? Right? That is the first question. So, before understanding what is Kubernetes, okay, let me let me share the knowledge on why Kubernetes. Why do we need a Kubernetes? And there's one of the reason is we love container. That's a simple reason. We love container and Docker container or container D. Container D is coming from the different tools actually. Docker is one of the tool which I taught you, but there are many other tools which can create a container. Okay, so please remember that. So we love containers. So earlier we were running a software in physical server 20 years before. Then we migrated to the virtual servers like EC2 instance, virtual machine on Azure and all on AWS. And then nowadays we are running a containers application in a containers. So we love the containers. Now, what is a container? What is the benefit of container? All these things we know that in the past last sessions only. But we are using a Kubernetes because of container only. So now the problem which we have is like what is the problem which we have in Docker or tools like Docker? So we are using containers. So the problem is very simple. If you start here, this is your host. There's one host, okay, and then you install the Docker. Okay, I'm using a Docker. Again, it can be any other. And here this Docker can manage the containers here. One container, two container, three container. Now there is a limitation, right? Host has a limitations. You cannot run X number of container, more than X number of containers. So let's say in this case we are running 3 containers. So now in the production we want to run 3000 container. That is something which you want. 3000 container. So how to do that? So if you say okay, we will add 1000 more nodes actually. Correct now? You will add 1000 more nodes. Agree with me?
Yeah.
So now the question is, who will manage these 1000 nodes? Simple. Who will manage these 1000 nodes? So understand in simple way. This is called container orchestration. running a container at the large scale. How do we deploy the new containers in the all this 1,000 host? This you can visualize as a 1,000 host. How can we run? How can we deploy the container in this host? That's a one problem. How can we scale up, scale down? How can we manage this host from one place? What about the security related? How do we manage the security of the container for on thousands of hosts? How do we manage networking? Okay, networking services on the thousands of hosts, storage, networking, security, load balancing feature, DNS, discovery feature. So many features you need. So many features you need to run your production server. So in AWS, what you have? See, in AWS, you can run machines using EC2 instance, but you can scale using auto scaling group. You can create a load balancer also using load balancer, Route 53 for DNS, storage using EBS, EFS, and S3, right? So all the services you have on AWS, so you are able to run productions instance using VM on AWS, correct now? So same way, if you are running a container and application in a container, you need all these features. So who will provide it all these features when we are running a application in container? And that is where you are using Kubernetes. So in nutshell, why Kubernetes? Because Kubernetes will help you to facilitate all the services which you need to run container in the production. Now, what services? So they will manage your nodes, worker node, these nodes. Okay, they will using Kubernetes. You can deploy the containers in all these thousands of node. You can set the size, you can reduce the size, you can increase the size, you can implement the networking services, you can implement the storage services, you can implement the security services, load balancing services, discovery services, and all these things, authentication services or authorization services. So you can use this container in the production. Without these services, it's very difficult to use it. So are you able to understand that why we use Kubernetes, all of you?
Yes.
Okay. So now because we know that why we need Kubernetes, without a Kubernetes, you cannot run containers at the production level. You need all the services. So now we can say Kubernetes is a container orchestration tool. This is the orchestration tool. Okay. Earlier, the Docker Swarm, which was launched, which was similar to Kubernetes, but that stopped because of could not survive in front of Kubernetes feature and so on. Many other companies also introduced many other features, okay, but could not survive. So yeah, Kubernetes is a container orchestration tool. Now this tool is managed by, introduced by Google, okay, and donated to CNCF. CNCF, who's the managing uh, Kubernetes. Now, I must ask you to go to their website and see the all of their products. Like Prometheus is their product, Kubernetes is their product, and hundreds of products they have it in CNCF. So in the old days, we had Apache. If you remember, Apache had a thousands of projects, and this is open source initiative and all. So same way, CNCF is also latest generation of cloud native projects. They are managing it, developing it, and getting done. So introduced by Google, but managed by CNCF. Just spend some time on the things. Now this tool is written in Golang, okay, and this is again free and open source, okay. So and open source. Now latest revision what you have is 1.25 if I'm not wrong, okay. So very stable product now, and very easy to. Now Kubernetes you can install everywhere. Simple. When I say everywhere means Kubernetes you can install on AWS, Azure, Google Cloud, VirtualBox, your laptop also, everywhere. Wherever you want to install it, you can do that. You can. So this is a little bit of introduction of Kubernetes. Any questions so far?
No.
Okay, so now we should know what is the architecture of Kubernetes. Okay, so Kubernetes architecture. So what is architecture of Kubernetes? So here in this, this is human, okay, human, and human use the tool called kubectl, okay, kubectl command, and that's kubectl has to be configured actually. I'll teach you all this stuff. Kubectl talk to API server, and API server, you know, talk to all other components. Okay, this is a very simple flow. Human means you and me using kubectl send the instruction to API server. Okay, but there is a much more than that actually. So what I will say, suggest, this is a worker machine, workstation machine. Okay, understand this. And there is a one master node, and there is a worker node. Now, master, you can have it more for HA, but I'm not complicating the discussion. Here, of course, multiple worker is needed. Okay, so worker means worker, master means master, workstation means workstation. Simple. So workstation means your laptop. I'll put it in very simple way. It can be your laptop. Yeah, that's your laptop. So that's a you. And in your laptop, you install what tool? Install kubectl. Understood? How to install and all, I'll teach you. That's not a problem. So in your laptop, this is the workstation. Master node, this is a VM. One VM it can be physical servers also, but nowadays it's all VMs, right? So this is a VMs also, and this is also VM. A VM means virtual machine. It can be anywhere in your laptop, or it can be on what do you say? It can be on Google Cloud or Azure, AWS, whatever it is. So now in the master VM, okay, what are the components you have? How this master node will become a master? So in this master, you have to install few applications. What applications? So you have to install applications like API server. Okay, there's a one applications. Then you need to install etcd, etcd. Then you need to install. There's a one more software which is controller manager. Okay, and then you need to install scheduler, schedular. I hope it is correct, right? So so in the master server, which is a VM, you need to set up these four software. So this four software will work in a certain ways, so it'll become a master. Are you understanding, all of you? All of you?
Yeah.
So now the question is, how do we set up a worker? So worker need to have few software, which is like kubectl. Okay, this software. Now before that, let me put it in kubeproxy. There's a software, kubeproxy. This software need to be there here. In fact, this has to be here also. These are the applications which you need to configure in the master. This application you need to configure in worker. How to configure? Just forget about it. I'll show you that. Now, few tools has to be installed in each of these machines. Which tools? So you need to have a kubectl here also. Okay, I'll put it. This is a tool. Okay, there's a difference between tool and application. Mind it. Tool is like one executable. Okay, and this is a applications. So kubectl. There's one more utility which you need, kubelet. There's one more utility you need a Docker. There's one more utility you need containerd. Okay, and if I'm missing a kubeadm, I'm missing it. So kubeadm. Now these are the tools. These tools you need to be keeping it in worker also. Yes, you need in the worker. That means tool sets are remain same for the worker and master. Only the applications will change. Are you understanding, all of you?
Yes.
Okay. So now what I was discussing, let me again come back from the top. In the Kubernetes architecture, we have workstation, that's your laptop, and that's where you have a kubectl, and then master server, which can be a VM anywhere, and has to have this software which I noted down, and these tools common for worker and master. And worker, you need to have a kube proxy, and here also you have need to kube proxy. So now the questions you will ask, what exactly master is doing, and then what exactly worker is doing. So simple. Let me show you the pictures here. This is you, and this is your laptop workstation, and here you have a kubectl installed. Here you have a kubectl installed, this one, and you send this instruction to the master server. This is the master server, which can be VM, and in this here you have instructions sent to API server. If you see that here, kubeless to API server. So here API server. API server internally they communicate with etcd, controller manager, and scheduler. Okay, these are the different software for different purpose. Right now I'm not complicating too much. So communication is being sent to here. Okay, API server, and now in this worker, this maybe multiple worker you have it, and the softwares are like a kubelet is running, which is agent. Kubelet is running here also, and then docker is running here. Docker is running as a service. Let me put it up this way. Kubelet is running here, docker is running here, a container day is running here, kubeadm is running here, kubelet here running. Same software here also you have it actually. Same software, kubelet, docker, containerd, kubeadm, all these things, whatever these tools. Okay, and then kubeproxy you have here. So what happens, the communication from here sent to uh, worker node, which is kubelet. This is a kubelet. Okay, and kubelet instantiate a pod. What is a pod, I'll talk about, and inside that you have a container. Okay, so here you send the request to API server, and API server will help you to get the container created in the world, all the worker machines. Right now is only one worker, but it can be multiple worker. So guys, did you understand the architecture at a high level? In Kubernetes, we have workstation, we have a master and worker. This master and worker, we call it a Kubernetes cluster. Remember, we call it Kubernetes cluster. Okay, and in the Kubernetes cluster, these are the components we have, software, and worker we have this software. These are the tools common for the every master and worker, and ultimately you can deploy your pod to the multiple worker. Pod, what is a pod? I'll discuss about it. A container, uh, you can here and this way. Are you understanding, all of you?
Yes, Rajesh.
So here, this is the master server. These all are worker, and this is the workstation. So you send any request to master API server, and the master deploy to the worker. So this is how you manage the whole architecture and all. Now we need to know what is API server in detail, etcd, cluster, controller manager, scheduler, and all, kubeproxy. So right now I'm just giving you one line definition, but in offline you need to spend a little bit of time, and then in fact this I'll convert into assignment also. So API server is a basically it's like a place, one application where all the request will be sent from workstation and internally also they will send to API server. Basically you can say it's like front end. All the internal component, okay, all the internal component and external, which is a kubectl in workstation, talk to API server. Basically using this you can communicate all, you can transfer all the communications to management communications to the API, to the Kubernetes. Now this is the storage actually. It's like etcd is a storage. This you can say controller manager is a kind of monitoring tool which will keep checking that what resources we have, what is the status of my cluster node, this that worker node and all. You can say scheduler is basically assigning the job to the worker. So it received the communication from IPS server and schedule this. This is the networking services. Kubeproxy is deploying the networking services in Kubernetes. And these are the tools which we have. So kubectl, which is used for sending a communication to API server. Kubelet is an agent which is running in the each machine, and kubelet only I said is creating a pod. If you remember, this is the pod, and inside that fill the container by Docker. Okay, so Docker is there. So now containerd is been used for creating a container. Docker was interface earlier. So now in the latest version of Kubernetes, Docker has been replaced with the containerd. And kubeadm is for the administrator of Kubernetes. So now let's say if you want to set up a master, what you need to do, I'll tell you in a fundamental way. You need to run this command. And this command, when you run, this all software which you see, it will be set up automatically. And in the worker you need to run this command, basically join. So any machines which you want to join, let's say this worker, this worker, this worker, this worker, you have to run this command to join the cluster. Okay, so overall this is the architecture. So we have a clusters, master, worker. These are the software which we have in the master, and these are the software we have and tools in worker. Are you understanding, all of you? Okay, so mind it here, this you can take it as a platform also. Kubernetes as a platform, like AWS is a platform. Kubernetes is also platform. So AWS, when you go, what you want, you do that VMs, right? EC2 instance, EBS, EFS, IEM, all these things, DNS services. So same way, Kubernetes also will provide you all these services, but for the container world, not for the VM world. Okay, so this is something which you have to understand. Now the question is, okay, you have to spend a little bit of more time on the architecture. In the LMS you have a detailed discussion about the 2 hours only on architecture. Okay, so I hope you'll spend some time over there. Now next question which we have is how to configure it. How to configure server. Okay, so first thing, I need one VM for master, at least one VM for worker, at least two VMs for sure I need it. So let me go ahead and open up my virtual box, and here I have a old VM here. If you look at this, so I will delete this because I don't want to confuse myself and you. So remove it. Okay, and this also I'll delete it. I could set up in the cloud also this VM, but I'm doing it in my laptop because that way you understand this and get it started. So here, yeah, okay, so here Ubuntu 20, okay, this one, and I'm going to clone this guy, clone one, and naming it Ubuntu 20 and create master, enter, full clone. Okay, now there's a one more clone I need for this, Ubuntu 20 K8 worker. So full clone. Done. So this is the master server, this is the worker server. Let me change the networking setting to bridge. So NAT to bridge. Okay. And NAT to bridge. If IP address will change in future, it will not work. So remember that. But good for the demo. This is one. Okay. Now what I'm going to do is I'm going to start this master server first. Okay, so I think done. Now username is I think root. Password is Rajesh123. Let's say Uber name username is Rajesh123. Yeah. So username is Rajesh123. Okay. So now what is IP? So IP if I see 7. So let me access to the putty. It will be copy paste will be easier. Here, first of all, this host name which I have, I want to change it actually. So Ubuntu, right? So that will be create a problem. So let me 192.168.1.7 and Rajesh and password is Rajesh123. Now I hope this is visible for all of you and click OK, apply. Done. Okay. So now I'll make a become root Rajesh123. Now the question is how to set up a master. As per the discussion, how do we set up a master? So actually theoretically, only this command is required you to configure and run. So this all tools will be set up, get in it. But these are the tools also needed. So many things has to be done. This tools has to be downloaded and installed. Then few configuration has to make, and then this all stuff has to be done. There are no straightforward things. So what I have done, I have documented everything on one script, so which will help you. So just come to here and type kubernetes 1.2 installation 1.2. So here I think this is a Google Cloud, is an older one. This kubernetes 1.29, this is also good, you can use it, but I am looking for the 1.23. So this is the one. So you see that Kubernetes 1.236 cluster setup master. This will work in the 1.2.20.4 only. So different instructions are there for installing in a different operating system. So I am showing you the Ubuntu here. Now Kubernetes 1.23 setup. So what you have to do, clone this repository and go to here. And in this repository, this script which you see, cluster setup latest. So this version which I'm installing, that 1.23. So this script is a shell script which has all the required commands which will help you to set up a master server. This script will do everything, but this script only work in the 1.2.20.2. So remember that. You can modify this script and make it work for the other versions also. That's not a problem. But if you really want to understand the logic behind step by step what should be done, then refer this script. This is for the master, this is for the worker. Okay. So let me run this command chmod 755
If you would have any issues with our channel membership, you can drop an email to us at contact@devopsschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Thanks for watching.